Let's do balanced binary tree. Given a binary tree, determine if it is height balanced. Height balanced is a binary tree in which the depth of two subtrees of every node never differs by more than 1. So in example 1, the root here never differs by more than 1. Our depth from here to the left side is 1, and our depth from here to the right side is 2. And the difference between these is 1, so it still validates the condition, and obviously the same for the subtree at 20 because that's going to be 0. In example 2, this is not balanced because you can see that if we go from the root, the depth on the left side is going to be 3 and the depth on the right side is going to be 1. So the difference is going to be more than 1. This tree over here, the subtree over here meets the condition, but once you go up to the root, this subtree does not validate the condition. Here are the companies that ask this question. So for this question, you might notice the word height in here, and luckily we do use the height function. So I'm going to write the recursive function to get the height of a subtree, which we have done before in terms of getting the diameter of a binary tree. So let's start with def height of root. And then if the root does not exist, then we will return a height of 0. Otherwise, we'll get the height of the left side and also the height of the right side. And then finally, we're going to return the height, which is 1 plus the maximum of the left and the right side. So if you don't know this function, it's good to remember because it just gets the height of a binary tree. And in this basic recursive function, we're going to write some extra things in order to determine if it's height balanced. So what I'm going to do is I'm going to make a balanced variable at the beginning. And it's going to be global because we're going to be using it in a recursive function. So self.balance equals true. And before I return here, I'm going to check if the absolute value of the difference between the left and the right height is greater than 1, which is basically what this definition is saying. So if absolute value of left minus right is greater than 1, then I'm going to set self.balanced equals to false. And then in the end, I can call the height function and then return self.balanced. This is going to be O of n time complexity because we are doing DFS through every node, and it's also going to be O of n space complexity because we are doing recursive calls that is basically equal to the amount of nodes.